This is the video for 8.2 and we are talking about multiplying polynomials. So I have here in example number 1 a monomial and I'm multiplying that with a trinomial. So how do I do this? Well, first of all, remember, negative x to the third power is the same thing as saying negative 1x to the third power. So I'm going to take this negative 1x to the third power and I'm going to distribute it to each term inside the parentheses. In other words, I'm going to take this monomial and I'm going to multiply it with each term inside the parentheses. And after I do so, this is what I get. So let me show you what I did with the first term. I took negative 1x to the third power and I multiplied it with 9x to the fourth power. So remember, the first thing you do is you multiply the coefficients together. So negative 1 times 9 is negative 9. Then you multiply the variables together. X to the third times x to the fourth is x to the seventh. Because remember what you do when you are multiplying powers that have the same base. You add the exponents. So that's what I did, and that's how I got this final answer. So go ahead and hit pause and work out this on your own problem. And there's the answer. Now we're going to start factoring. Factoring, remember, is breaking something down into its individual factors. And remember what factors are. Factors are what you multiply together in order to get something. So I have a trinomial. And I'm asking you to factor out the greatest common factor. So the first thing you need to do is identify, well, what is the greatest common factor? Here, the greatest common factor is 5x. So how do I know that? Well, first, you look at the coefficients. You have 5, 25, and 45. So what is the greatest common factor of 5, 25, and 45? 5. The greatest common factor of those three numbers is 5. Then you look at the variables. I have x to the third power, x squared, and x. What is the greatest common factor of the variable x? Or excuse me, what is the greatest common factor for the variable x of these three terms? And the answer is x, or x to the first power. Because the greatest common factor for your variables will always be the variable with the lowest exponent. And here, that's x to the first power, or x, or just x. But let me show it to you this way. Just to make sure you understand, x to the third power is 3 x's. X squared is 2 x's, and x is just 1x. And so how many variable x's do they have in common? 1. So my greatest common factor for the variable x is going to be x to the first power, because that's what they have in common. That's their greatest common factor for the variable x. So after I factor out the greatest common factor, this is what I have left. So this is my answer. This is the final answer. How did I know that after I factored out the greatest common factor, this is what was going to be left? What you're doing is you are dividing each term by the greatest common factor. So let's just look at this term. I had 5x to the third power, so I took 5x to the third power and I divided it by 5x to the first power. So first I divide my coefficients. 5 divided by 5 is 1, so this is 1x squared. And then I have x to the third power divided by x to the first power. And remember, what do you do when you are dividing powers that have the same base? You subtract the exponents. So that's how I got the answer here, and I did that with each term. Now, it's very, very important that you understand. It's very important that you understand this and this, what you began with, are mathematically identical. Your final answer here and what you began with, what the problem originally gave you, are the exact same thing mathematically. So how do I prove that? So we divided out the greatest common factor here. So multiply it back in. Once you multiply it back in, you should get the same trinomial that you began with. So now let's look at the next example. I have another trinomial and I'm asking you to factor out the greatest common factor. So the greatest common factor here is going to be negative 4x to the third power. So let's look at my coefficients. I have negative 4, negative 24, and 8. The greatest common factor is negative 4. Now, why did I say negative 4? Because the leading coefficient, or the coefficient of your first term when you get your final answer, must be positive. That's the rule. So if your leading coefficient is negative, you have to factor out that negative as well. Now, how did I know that it's x to the third power? Well, looking at my variable x, the lowest exponent is 3. So that means I can factor out 3 x's out of each term. But let me show you so you fully understand. X to the 7th is 7 x's, x to the 5th is 5 x's, and x to the 3rd is 3. So what do they have in common? They have 3 x's. So that's my greatest common factor. And then you can see how many variables I will be left with in each term after I factor out those 3 variables from each term. I have 4 variables left in this term, I have 2 variables left in this term, and I have no variables left in this term. So this is my final answer. This is what I'm left with once I factor out the greatest common factor from each term here. And again, what exactly am I doing here? How do I know this is what I'm left with after I factor out the greatest common factor? Well, what you're doing is, again, dividing each term by the greatest common factor. And this is what you have left. So, remember, this and this mathematically are identical. And how do I know that? Well, let me prove it. And always do this to check your answer to make sure that you factored it correctly. I had divided the greatest common factor out up here. So now let me check my answer and let me multiply it back in. And this should be the same thing as what you began with. So now I have 3 on your own problems. Go ahead and factor out the greatest common factor from each trinomial. And here are your final answers.